Oh, hi, I didn't see you there. Today we are going to demonstrate two of the four elemental forces with the objective to comprehend them better with my classmates Luis, Diego, Armando, Joaquin, Santiago, and myself. Now we'll see the first experiment, which is obtaining energy from lemons.
In this experiment, we are going to use 4 lemons, crocodile tips, sticks of zinc and copper, and an energy meter.
For the procedure, the first step you're gonna need is to take the metal sticks and the lemons. You're gonna take one copper stick and one zinc stick, so in total 2 sticks. You're gonna put them in one lemon. You're gonna have one copper stick and one zinc stick per lemon until you form a chain of 4 lemons. Then you're gonna take all the crocodile cables and connect them. The copper sticks with the zinc sticks and vice versa, the zinc sticks with the copper sticks. You're gonna form the chain, but be careful, the sticks shouldn't touch each other. If they touch, the experiment won't work. And for the final step, you're gonna take your electric meter and connect the cables with one copper stick and one zinc stick. Then the lecture might show up. If it doesn't show up, it means that either you connected something wrong or that the sticks are touching each other. On this experiment, we were able to do both. Get an electrical lecture of 2.86 and turn on the LED light.
The energy that the food has is chemical that can be transformed to electrical energy.
Citric acid functions as an electrolyte that allows the voltaic cells to conduct electricity.
Meanwhile, metals in this experiment function as electrodes which allow the transfer of electric current from one lemon to another, as shown in the picture of the bottom left corner. Now that we have all that information, we have to establish a relationship between the results of the experiment and a tool that we use on a daily life basis. We also have to identify which of the 4 elemental forces is being represented in this experiment.
The relationship between this experiment and a car battery is that they convert energy, they both use acid and it can dry out if you use them a lot. They also have opposite poles.
In this experiment, it's electromagnetism because it is the one in charge of electricity, and the cables are connected negative to positive. And we were able to identify it thanks to the LED and the electric meter. With this, we are able to identify an example of one of the fundamental forces.
And we also concluded that electromagnetism is the fundamental force present in this experiment because of the photons, which produce light. And in this experiment, the LED was lit up by the lemons. We as a team concluded that this experiment is pretty efficient at the moment of making us identify which of the 4 fundamental forces is putting into action. And it's also challenging because of the questions that have to be answered and the research that has to be made in order to answer them.
Now we'll see the second experiment about probability with dice and coins. This experiment has the objective to demonstrate how many tosses or half-lives it takes for an atom to decay. Let's go!
In this experiment, the materials we're going to use are 25 coins of 1 peso and 15 dice.
We're gonna begin by doing the coinium experiment. For this experiment, the coins represent the atoms of the coinium radioactive element. So you're gonna have to make a circle for the coins not to go anywhere and start tossing the coins. The coins that lay with tails up, you're gonna have to collect them again and throw them again until they are all on heads.
There is a probability of 50% that the coin can land up on head with any toss.
When all of your coins face up on heads, you're gonna have to make a table. This table has 3 columns. The first column will represent the times you toss the coins, or the half-life.
Half-life. The constant time period required for the disintegration of half of the atoms in a sample of some specific radioactive substance.
The second one will represent the number of undecayed atoms, or the atoms that lay on tails. And the third one will represent the decayed atoms, or the atoms that face up on heads. With the results of your table, you're gonna have to make a graph. This graph is the next one. As we can appreciate, it is an exponential graph, in which with each toss that we make, the number of undecayed atoms decreases until it reaches 0. For this experiment, we were able to get all the decayed atoms on only 7 tosses, as shown on the next table and graph. For the Dicenium experiment, you're gonna have to take all of the dice you have. You're gonna have to toss them. The dice represent the atoms inside of the Dicenium radioactive element. You're gonna have to look for all the dice to land on either 1, 2, 3, 4, or 5. If the dice lands on 6, you're gonna have to toss them again. This because 6 represents the undecayed atoms or father atoms, and when they face 1, 2, 3, 4, or 5, they represent the decayed atoms or daughter atoms.
There is a possibility of 16.6667% that a die will land 6 side up.
Similar to a case of the Koinium experiment, you're gonna have to fill in a table. This table has the same characteristics as the Koinium. Half-lives, undecayed, which are the ones that landed on 6, or decayed, which are the ones that land in either 1, 2, 3, 4, or 5. Then with that table, you're gonna have to make another graph. This is an exponential graph as well. However, the number of tosses decreases, as there is a lower possibility for a die to land on 6 than on any other number. For the last experiment, we were able to get all the decayed atoms on only 3 tries. This due to the higher probability that a die has to land on either 1, 2, 3, 4, or 5 rather than 6.
The data that we obtain is similar to the theoretical predictions.
In a way that with each toss, the probability increases to obtain a decay.
We can relate both of these experiments with radioactive decay in a way that both are random. Radioactive decay occurs in a random period which increments at a constant level of 50% or less or more, depending on the time period, and the coins and die were depending all of them to be either heads or 1, 2, or 3, 4, 5s, depending on the probability of randomness. It can also be related with radioactive decay because the result changes. In the coins, it's either heads or tails. In die, it's either a number from 1 to 6. And radioactive decay is the change of the nucleus of the atom that changes the isotope. For both the Dicenium and Koinium experiments, we conclude as a team that the fundamental force present is weak nuclear force. This because of the presence of radioactive decay and the importance that probability has in both of the experiments. And as a general conclusion of all the experiments present in this video, we conclude that they were interesting in a way that we were able to identify which fundamental forces are maybe present on our daily basis. We also learned some new terms such as half-lives, undecayed, decayed, and radioactive decay.
We use 2 cell phones, one to record the audio and one to record the video.